Hello the internet and welcome back to my channel. This is the continuation of part 1 and 2 of my IBM PS2 Model 30 repair and restoration. On the previous video we fixed the motherboard and we fitted a new battery holder, so the system is 100% working. On this video we're gonna take a look at the floppy drive and the hard drive, which are completely dead, and we'll see if we can fix them. Later on in the video I'm gonna use some PCBs which I'm gonna use for these PS2, and all the PCBs are kindly provided by our sponsor, PCBWay. Now, this repair hasn't been easy, so as a result I ended up with an awful lot of footage, which I was really struggling to put together in a way that the video is still enjoyable, but also in a way that the length of the video is reasonable. So I decided to go with the voiceover this time, and I would appreciate your comments down below about what you think about this format. But enough me talking, I would say let's take a look at the floppy drive and see if we can fix it. First of all, let me thank the many of you who helped me out on this project, suggesting that these drives often fail because of bad capacitors. My viewers, Vogons, the RetroWeb, and also Epictronics. Thank you very much. So, it looks like it's not the capacitors on the top PCB which fail, but the ones at the bottom. Now, if I see this right, the bottom PCB only controls the spindle motor. Everything else is connected to the top PCB. The heads, head stepper, sensors and switches. So I'm wondering if this has something to do with the speed of the drive then. You know that whenever I can, I don't like to throw parts in my projects. So out of curiosity, I'd like to check the rotational speed of this drive. Now, coincidentally, I have a tachometer, which I bought many years ago and really never used. The tachometer measures the rotational speed of things. So this works both by contact, by attaching one of the many rubber attachments provided, or by non-contact, by emitting a red light which reflects on this supply strip of reflecting material. The tachometer then counts how many times per second the emitted light is coming back to the integrated sensor and gives back a number. All I have to do is to attach a square of the reflective strip to the rotor and measure. And the drive spins at 600 RPMs. This is supposed to read 300, so it seems that the issue is actually the speed of the drive. First of all, I have to take the drive out of its cage to access the components. Now let me check those capacitors in circuit. This one is a 1 microfarad, and it reads something, but it's in circuit, so who knows, but at least it reads something. This is a 10 microfarad and it reads 10 microfarad, so maybe this is okay. This one is another 1 microfarad, and it doesn't read anything. Also, it's close to this little coil, which I guess is activated when the magnet glued to the rotor passes by, so maybe it's got something to do with the speed. Well anyways, let's remove those caps and test them out of circuit. Now, I don't like the plier method to remove SND capacitors, and also I would like not to break them so I can test them. So I'm going to use my soldering iron and a little bit of patience. Here we are, these are the capacitors, so let me check with the component tester. This one is the 1 microfarad and it only reads 638 picofarad, which is not good. This is the 10 microfarad and it's okay. And this one is the other 1 microfarad, which also reads bad, and the ESR is in kilo ohms. So we have two winners here. I don't have SND capacitor, so I'll have to place an order. But meanwhile, I'll botch something through hole for a test. Oh yes, I know this is a bit precarious, but it'll do for a test. I'm curious to test the speed now. And would you look at that, 300 RPMs. So that was the problem. Thank you very much everybody for pointing me to the right direction. Now I'll have to condense like a week of footage in a voiceover. Basically the drive was showing signs of life, but still not working. I had the non-system disk shown on screen sometimes, which meant that the floppy was being read as that message is on a file stored on the disk. But it was really temperamental. Sometimes I would get them error, sometimes I would get error 601, which is diskette drive error. Sometimes it would try to boot, but fail while doing so. On one occasion though, the drive actually managed to boot into MS-DOS, and I guess that's the first time in decades with this drive. At some point, I managed to run check it off camera, and the floppy test was showing lots of errors. But it was very temperamental. Reboot might break it with error 601, requiring a power cycle. I have hours of footage with me fiddling with this floppy drive, and every test I did yielded a different result, so it was really difficult to understand what the problem was. At some point, I went ahead and decided to replace all the capacitors on the top board as well, but those tested all fine and did not change anything, unfortunately. I thought maybe my floppy disks were bad, the same that happened with my Macintosh SE repair video, which I recommend if you want to see me struggling with floppies and many other things. To be honest, this floppy is from the same batch, but I tried brand new 144MB, the best 720K I have, and none of them work reliably. This is the 720K diskette I've been testing on the PS2, and it works totally fine on my Pentium test bench, which I've been using to create these very floppies. So, because the drive seems to be working at times, I decided to reflow all the ICs and solder joints. I did not see issues with them, but you never know, and I'll have to start from somewhere. Once I put the drive back together, it actually worked, but let's not celebrate too early as I've seen this before for short times. Let's check it and run a floppy test and see if it passes it. Well, it passed the test, but let's keep crossing our fingers as I've seen this before off camera. One thing I've noticed is that the drive refuses to format disks. It comes out with this timeout error. And if I run the IBM diagnostic, all the utilities show this no index pulse error message. But at least the drive seems to be working, right? Wrong. After some further tests, the drive stopped working again. When that happens, I feel the head is struggling to move, and also it's supposed to seek a power up, and it doesn't do that, or very faintly. Meanwhile, I think I found what that index pulse is. It should be the spinning magnet we discovered when we replaced those capacitors. I can scope it here on this connector, so it does reach the board. I need to find out where it goes and how it reaches the computer, and hopefully I can trace where it stops. So the pulse is coming through this resistor and it goes into this logic chip. This is a 74HC08 and it's an AND gate. The way an AND gate works is very simple. There are two inputs and one output. Only when both input signals are high, then the output is high. Any other combinations will result in a low signal. So let's check the inputs. One is my pulse, and yes, I can see it here. In order to have this pulse at the output of this logic IC, I need the other pin high, or the output is always going to be low. But the other pin is low all the time, so obviously the pulse stops there. However, a few minutes later I got the drive working, as in it boots up and it's doing something in between failures. And if I test again, the second pin, the one which was always low a moment ago, is now always high, and as a result I now have the pulse signal going through the IC. What I did was to cool down those transistors you see nearby, which is where I think the affected pin is going. Well, the transistors seems to be working on the component tester, but being so temperamental, I wonder whether maybe this is an expected behavior and maybe they're just working intermittently. So I replaced them anyways. These are NPN transistors, but with an integrated biased resistors connected to the base, so I'll have to add a small resistor myself. When I tried again, the floppy worked, which is a good sign, but still refused to format. But maybe this index pulse error is something else. For now, I'd be happy to have this drive just working reliably. But no, a few minutes later, it failed again. Oh, this is getting so frustrating. After further tests, I think I discovered what the faulty component is here, and I think it's the AND gate we were talking about. Now, unfortunately, I could not capture that on camera, but I could reliably make it work by using some cold spray on it, and it would then stop working when warmed up. I did that 4 or 5 times, then I turned on the camera and I could not replicate that anymore. To me, it's obvious there is an issue in this area. Now, my programmer, the TL8662, Can test logic chips, so I'm going to remove this logic IC and test it. Okay, this chip is out on the adapter for the programmer. So let's select the correct IC and test it. And the programmer says it's not good. That's amazing. Now, I understand this programmer is not great at testing logic ICs, but apparently if the 866 says the chip is faulty, then it must be bad. So let's get me a replacement and finger crossed. Replacement has arrived. I had to choose a slightly different package as the one installed is an old standard, which is difficult to find. But thankfully the pads are very long on the PCB, so I won't need to adapt it, it will just work fine. Now, out of curiosity, let's test the new logic IC on the 866. Okay, yes, it works. So let's install it on the PCB. Oh, and by the way, meanwhile the SMD capacitors have arrived, so let's install them as well. Right, the drive is back in one piece. Let's power up. Okay, it works, but we know it can work intermittently. That said, I feel the head is making a different noise, as if it's moving in a less erratic way, if that makes sense. Can I format the disk now? No, I can't. Oh well, let's run check it and see what happens. Now I'm getting this disk changed error. Oh my gosh, this never ends. Okay, so no luck. I feel that something's changed, but the drive is still misbehaving. Now check it refuses to work altogether, but the drive seems to be able to boot most of the time. No more error 601, which can only be cleared by a power cycle. It might not boot, but a simple reboot usually clears that out. That said, I can clearly see and hear the head struggling when booting up. Check this out. After more and more tests, believe it or not, but I can trigger the boot no boot issue by warming up and cooling down the adjacent logic IC, which is a 74HC74. It's a dual flip-flop. This time I can show you that. Let me cool down this IC with some cold spray and let me restart the computer. It's booting up now, at least it's trying. Now you see the head working as expected while booting MS-DOS, so all good here. Let me try this again. There you go, still booting up totally fine. Okay, so it works. Now I'll warm up the IC using my hot test station. Okay, the chips are warm enough, let's reboot and see what happens. And it doesn't boot, look at that. Let me cool down this chip and reboot and see what happens. And it works again. So everything points to these 74HC74. Now, does this drive have two bad logic ICs? Well, there's only one way to find out. Let's remove it and test it. And would you believe that? It's faulty too. Something must have happened to this board drive. You know what? There are two more logic ICs on this board. I'll remove them both and test them. Well, I'm in luck this time. Both ICs test fine. That said, as I said, I know the 866 is reliable when it says something's faulty, but not when it says something's good, so maybe I'll order some replacement anyways, you never know. Okay, the drive is back in one piece, I've got the faulty IC replaced, but I just resoldered the other two logic ICs, which seem to be working fine for the time being. Let's test the drive. Well, the drive boots, which is not unusual. Let's run check it and test. Oh well, the test passed and the head seems to be moving with no hesitation this time. Do you think I managed to fix this drive? Do you think it can now format diskettes? Well, let's try that out. No, I still cannot format it, and the IBM utility is still complaining about missing index poles. And my optimism was short-lived because, would you believe that, the drive started misbehaving again after a while. I don't understand. I've replaced faulty capacitors and faulty logic ICs, and this drive is still not working. At times the drive gets kind of stuck, and if I reboot the computer I get error 601, which can only be cleared by a power cycle. Then the floppy works fine for another while. However, the drive seems to be working a bit better now. That means that the drive works reliably until it stops working. No more hesitation in the head moving or random error messages when testing. The drive works fine and tests good until it stops working altogether. At that point, a power cycle usually revives it. Oh, and obviously I still cannot format the disk, and IBM Diagnostic is still telling me there is no index pulse. At some point during my diagnosis, I discovered that the signal exchanged between the drive and the motherboard are kind of human readable. I'm not sure why I thought it would be a single, large, cryptic, digital stream of data, but it's not. This is the pinout of the floppy. As you can see, besides the write data and read data pins, which streams the actual data being written and read by the heads, everything else is directly controlled by the floppy controller, which is on the motherboard. So it's the motherboard to tell the head to move and in which direction. It's the motherboard which directly selects which head to be used and turns the motor on and off. And some signals from the drive, such as whether the drive is write protector or the track 0 signal, are going straight to the floppy controller on the motherboard. This makes this troubleshooting a bit more interesting, as we can check the signals with an oscilloscope. So let's start with the stepper motor for the heads. As the name suggests, a stepper motor moves in small steps. The driving logic needs to know which direction it has to rotate the motor, and it needs to know how many steps it has to progress. For that, the motherboard sends a direction signal and a step signal, which is a pulse signal with each pulse representing a step of the motor in the direction indicated by the direction pin. So to move to a certain track, the floppy controller will have to send a known number of pulses to the motor, and the motor will step onto the correct track. Let me show you. Right now I'm running the floppy test routine of Check It, so the heads are constantly moving back and forth. This is pin 18, the direction pin. As you can see, the heads movements are following the signal on the scope. When the heads change direction, the signal changes from low to high and so on. Now you can see pin 20, the step pin, which are the pulses sent by the controller to actually move the head of a known amount. This is pin 30, the actual data read by the heads. It's just a bunch of digital stuff here, but as you can see, it only happens after the heads have reached the desired track. Pin 32 is the head select pin. This is the signal telling the drive which head, top or bottom, should be sending data to the controller. Check It is now alternating between head 0 and head 1, and as you can see, the signal is following that as it changes between low and high to select heads 0 or 1. Next we have track 0 on pin 26. On this drive, track 0 is an infrared sensor which senses a plastic flag which interrupts the infrared beam when the heads reaches track 0. Check It is doing a random SIC here, but he will read track 0 in a moment. And there it is, the heads reached track 0 and the signal went low. The next pin is diskette change, which is pin 34. This pin gets low when the drive has sensed that the floppy has been changed. There is a small micro switch which is engaged by a diskette when it's inside the drive. If I run a simple dir command, the signal is always high. But if I eject the floppy and I put it back in, the next time I type dir, the disk change pin goes low for a moment, and this is the drive telling the controller, hey, there is a new diskette inside. Finally, on pin 16 we have the motor enable pin, which is physically controlling the spindle. The signal goes low when I type dir, which is when the motor starts spinning, and goes back high when the motor stops. Now let's get to the most interesting pin here, pin 8, the index pin. If you remember, the IBM diagnostic complains that the index pulse is missing. And unsurprisingly, there is an index pin on the connector, so let's check pin 8 and see what's on it when the motor is spinning. And there is nothing. The signal goes low, but there are no pulses there. But when I check the same pin on my Panasonic drive, the index pulse is definitely there. And this is great, so now I have something to look into. Let's trace pin 8 on this PCB. It goes into this logic IC, it's a 74HC368, which is an inverting buffer. Basically, it's used when more devices are sharing a bus. It lets the input signals going through the outputs when an output-enabled signal is received. And this is to avoid bus conflicts, so only one device at a time can use the bus and talk to other components. Pin 8 on the connector is linked to pin 7 of the logic IC, and the input for pin 7 is pin 6. So let's check whether we have a pulse at the input of the buffer. And we do not. Now, I've traced this line down to this Mitsubishi chip, which I think is the main logic controller for the drive. This one on the right seems to have something to do with the read-write of the heads, while these smaller ones on the left is probably responsible for managing all the other signals. I trace the buffer input onto the pin, and if I scope it, it still does not output a pulse. Now, for the life of me, I cannot find any information on this IC, so unfortunately I'm stuck here. As my final steps, I did check every single discrete components on the board. I removed every single transistor and tested them. I checked diodes, resistors, everything. I even reflowed the vias. And I also replaced those two logic ICs just in case. Nothing helped. I do believe this Mitsubishi IC is faulty, and unfortunately I'm unable to find any documentations about it, and no replacements are available. It is very frustrating, as I identified 3 different faults on this drive, and it's really sad to have to give up, but I'm really stuck. If someone could help me on this, I would love to be able to get this drive working properly. If you know anything about this IC, or if you have a broken drive which you don't need anymore, please do get in touch. Meanwhile, the drive kinda works. It basically works fine until it stops working, so I guess it's better than nothing while I look for a more permanent solution. Let's now focus on this hard drive. We tested this hard drive on our previous episode. It was spinning but not working, ending up with some flashing error code on the LED. The noise it made could indicate some mechanical problem with the head movement. Now, this drive is old enough to use a stepper motor to move the heads and not a voice coil. The upside of that is that I believe I can access one of the 2 bearings under the sticker, and maybe also manually exercise the heads if the mechanical is stuck. Also, let's not forget the corrosion I discovered on the ribbon cable, which I believe goes to the heads. I will have to take a look at that at some point. For now, let's go with the usual. Let's add some lubricant to the stepper motor and see if that helps. Thankfully, there is a rubber seal here under which I can see the ball bearings, so that's perfect. I'll add some drops of oil here. That unfortunately did not help, and the drive is behaving as before. Next, I'd like to try to run the drive with the heads disconnected so that I can see the stepper spindle. Okay, well, yes, it could be stuck. It seems that it's trying to move, but it fails to do so. It could be a mechanical problem, but also a driving problem from the stepper driver. But before I do more tests, I'd like to check that ribbon cable going to the heads. Because one scenario is that the logic cannot see the heads, and the stepper just doesn't do anything because of that. Now, as you can see, this flat cable is corroded under the protection layer. To test for continuity, I'm going to sand away some of the protection where there is no corrosion using very fine grit sandpaper. Once I have the copper exposed, I should be able to test continuity between the copper part and the edge of the cable which is going into the connector. Well, the good news is that there is continuity, so the cable is fine. But the bad news is that my options are narrowing now. My next idea, which is definitely not recommended but kind of accepted if you have no other options, is to manually turn the stepper motor to see if that causes something to get unstuck. For that, I'm gonna use the rubber at the end of the spindle to turn the spindle of the motor. And yes, I'm aware that rubber also means something else in the US. Okay, well, the motor seems to be free to spin, so that eliminates a mechanical problem, I guess. Now I'm going to manually turn the spindle so that the head reaches the other end of the track, which I think is the innermost position, close to the center of the platters. Then I'll power up the drive. What I would expect is the stepper to move the head back to track 0 if all works correctly. Okay, I think I've reached the end of the movement, so let's power up and see what happens. Okay, so the motor rotates a few degrees counterclockwise at every power up. If I keep rebooting the computer, eventually the stepper will be back to where it was, and the noise it was making was just the head reaching the end of the track. Not what I was expecting, to be honest. But what saddens me most is this grinding noise I'm hearing now. Clearly the heads are rubbing against the platter, and I guess this drive is now dead. I'm not sure if I killed it. I was assured that moving the stepper manually was okay for a test. Chances are this drive has been dead all the time. Not much I can do probably. There still could be some logic issues on the board, but this grinding noise really does not make me want to invest any more time and money on this drive. One last thing, the easy one. Let me check some of these capacitors. These are 6.8 microfarad. They do test okay, but the ESR is very high. Now, high ESR for low capacitance is kind of okay, but 35 ohm maybe is a bit too high. So I replaced them with some tantalum. Those should have very low ESR by nature. I was not expecting much, and no, that did not work either. So it looks like we have a partially working floppy drive and a dead hard drive. Ideally, I'd love to have another one of these squeaky IBM drives, but I'm also aware that they will eventually fail. The only temporary solution I can think of is to take advantage of the ISA bus of this model and add a regular IDE drive using XT-IDE. Now, I do not have an XT-IDE, so PCBWay came to help here, providing the PCBs and also sponsoring this video. The project page for the XT-IDE revision 4 is in the description. As usual, the process is very simple. First, you need to download the Gerber file. Then you navigate to PCBWay.com and head to the PCB Instant Quote section. From there, you select Quick Order PCB, add the Gerber file you downloaded from GitHub, and the website should automatically load the file and load all the parameters for you. For my boards, I chose the red solder mask, which came at no extra cost. Finally, you select the shipping option, and it's done. The resulting PCBs are pretty well manufactured as usual, and I really like the red finishing. I'll save you the assembly of the board, but it's pretty fun to put together a PCB and then turn it on and see it working. Thanks PCBWay for your help again. Okay, we got the XT-IDE connected to the motherboard. It is a bit precarious, appreciate it. This whole system is designed to be installed into a case, to be stable. I just didn't want to install it into the case for the time being, so I got this little piece of wood just to make sure that nothing horrible happens. I've got an empty 512 megabyte compact flash. We're not going to use 512 megabyte, of course, with the MS-DOS that we're going to install. And for this occasion, I've got this. These are IBM 1 megabyte floppies that I got a few weeks ago, brand new sealed, all stock, and I thought it was a bargain, and I was so happy to finally have found brand new 720K floppies. Unfortunately, despite being sealed, they are in a pretty bad state of conservation. The surface of the media is a bit moldy, so I can kind of revive them by basically formatting them over and over again until the heads stop making a horrible noise. Which means the heads are scraping away whatever is on the floppies. It's horrible. These are never going to be totally reliable, but I can kind of make them work, and we'll see if that works on the system. They are absolutely amazing. They come in this individually wrapped in this plastic envelopes with colored labels. They're absolutely amazing. And as you might be able to see, they have an IBM logo on it. So these are perfect for this project. So I went ahead and I made an IBM DOS 3.30, which is basically the operating system which came with this machine. At least that's the one I used to run when I was at school and I was using these computers. So let's go ahead, let's try to install this operating system on this very machine and see if that works. Okay, so let's put the operating system floppy into the drive. Let's power up this machine and let's install it. And we are into IBM Personal Computer DOS version 3.30, absolutely amazing. So the first step would be to partition the disk with fdisk. Okay, so the first step is to create a DOS partition. This compact flash should be completely empty. Let's have a look with number 4. It is completely empty. So let's create a DOS partition here, primary partition, and let's use the maximum size that whatever the operating system is happy with. The system now is restarting. And we are back to PC DOS 3.30. Now, I had to look up a bit to understand how to install IBM DOS 3.30 onto a fixed disk, and it turned out that the setup file was created later on a later version, but on 3.30, the command to install the operating system onto a fixed disk is called select. So to install the operating system onto my compact flash, the command should be select from A to C, country code, which in the UK is 044, and keyboard, which is UK. And that should take care of the formatting of the disk and the transfer of the operating system, including the boot files. Let's have a look. And it's done. As you can see, back in the 90s or 80 something, the installation of PC DOS was very, very basic. There was not much communication from the computer, not much was happening, and you end up with this very cryptic prompt without much information about. So the system should be now ready to be booted from a hard drive. So let's remove the floppy and let's restart and see if it works. And it does work, look at that. So this is loading from the hard drive, and we are on IBM Personal Computer DOS version 3.30. Amazing! And I can see that, I don't know whether it's the XT-IDE or the operating system, the BIOS, whatever, it has selected a drive of 32 megabytes, which for the time, it was quite a lot. That's probably the maximum that this system can recognize. As a final touch before wrapping up, I really wanted to wash this motherboard. It looked sad and I didn't like that. I used Electrolube SWAS, which is a water-based chemical designed to wash PCBs in ultrasonic machines, but it's okay for manual wash as well. It's not cheap, but I love it, and it can be reused. It really removes all the grime, but most importantly, it removes most of the oxidation. After washing and brushing the board, I rinsed it with tap water and then I gave it a final rinse in distilled water so not to have mineral deposit left behind. Then I used compressed air to dislodge as much water as I could, and finally I left it out to dry for several days. The result speaks by itself. The board looks brand new and it's so much happier now. I'm incredibly happy with the outcome. Well, we got to the end finally, and it hasn't been easy, and I'm a bit disappointed that on this occasion I wasn't able to fix this floppy drive 100%, but that being said, I've been playing with XT-IDEs and DOS 330 for a couple of days, and the floppy drive performed perfectly well. It never had a single issue, never had to restart the computer, so maybe it's okay for casual use. That being said, I'm still looking for a permanent solution whenever it comes by, but for now, this is pretty good, considering where I started from. Well, I guess this is it. I hope you enjoyed this video. If you did, I would really appreciate if you could hit the like button down below, and also consider subscribing to this channel if you like what I'm doing here. For now, thanks for watching, I wish you a great day, and I hope to see you again soon here on this channel for my next videos. Thank you very much, and goodbye. Bye bye.